So today we will carry on with our work on sequences, and specifically we'll look at something called nth term. You've probably seen this written a few times now in different contexts and situations, but we'll really focus on what do we mean by nth term in today's lesson. Now you've already seen some sequences, and last time we covered the idea that you can jump directly to any place in the sequence that you like. So for example, if I wanted the 100th term in this sequence, I can use this rule up here. It wouldn't be necessary to work out the first 99 terms in order to find the 100th. So let's just go through that one again. Suppose I wanted to jump straight to the 100th term of this sequence here. I want the 100th term. I'm going to use this rule. Well, first of all, notice that the difference then is 4. It's going up in 4s, isn't it? We go add 4, add 4. And the 0 term here, well, 4 less than 5, the one before the first term, that would have been 1. Okay, 0 term is definitely 1. So if I apply this rule up here, difference times term number plus 0 term, the difference we've just established is 4. I will multiply that by the term I want, in this case 100, or the 100th term, and then add on the 0 term here, positive 1. I don't think I need a calculator for that one. That's going to be 401. 401. So the 100th term in the sequence is 401. How about the 60th term? Okay, if I want to know what the 60th term is. Alright, I'll use this rule, difference times term number plus 0 term. So 4 is the difference. 60 is the term number I want. 0 term we've established is 1. Well, 4 lots of 60 is 240. So I think that gives me 241. Okay, maybe let's try the 38th term. The 38th term in the sequence. Let's jump straight to the 38th term in the sequence. The difference between each one is 4. Difference is 4. I want the 38th term. So times by 38. The 0 term is 1. 4 38ths are 152. So this gives us 153. Okay. Now you will notice in each of these there's always this 4 times term number plus 1. Of course it's always 4 and 1 because it's the same sequence each time. I'm just trying to jump to different places in the same sequence. So this 4 and 1, that doesn't ever change for this particular sequence. It's always a difference of 4, it's always a 0 term of 1. That won't change. So I could put any number I like here. That changes that bit there, of course, a bit in black. I could even say, what's the nth term? It doesn't have to be a number. We know how to do algebra, so same again. So difference is 4. I want to find the nth term. Term number is n. And the 0 term is 1. Well, 4 times n is always written as 4n. You just squash the symbols together, right? That's how you write multiplication in algebra. We don't bother with the times sign. 4n plus 1. We can do any letter, but traditionally we use n when we're doing sequences. It's just standing for any position at all in the sequence. It's nothing scary. It's just saying to get anywhere in the sequence, do 4 times that, then add 1. Let's do another example. So let's jump to, say, the 200th term. Why not? I want to work out what the 200th term in this sequence is. Okay, well, I'll use the rule difference times term number plus 0 term. The difference in this one, notice what it's going up in? It's going up in 7s. Plus 7, plus 7, plus 7. Always adding 7 each time. So the difference for this one is 7. So difference times term number. Here the term number is 200. I need the 0 term. The 0 term is the one that comes before the first term. Well, 7 less than that is 13. 13 would have come before the 20. So I'll add on 13. 7 lots of 200 is 1,400. So I get 1,413. Okay. Suppose I want to jump to the 3,000th term. It really doesn't matter. Okay, so the difference is 7, term number is 3000, 0 term is 13. Okay, well, I know 7 3s are 21, so this must be 21,000, so it's 21,013. You are welcome to use a calculator for these if you want to, if you need to. Okay, I could carry on doing this all day. I could keep picking random positions in the sequence if I wanted to, just to demonstrate, but I hope you see that for this particular sequence, it's always going to be 7 times term number plus 13, because the difference won't change. It's always 7, the difference. Term number is 13, that's not going anywhere. So it's always 7 times term number plus 13, even if I want to go to, say, a lettered term, the nth term. Same principle, 7 times n in that case. And the 0 term, 13. When we're writing that, we just ditch the times sign, don't we? You know how to write in algebra. 7 times n is written as 7n. So 7n plus 13. I'd like to whiz through a few more examples. For the other examples, I'll go straight to the nth term. I won't bother with working out, things like the 200th term or the 38th term. I'll go straight to the nth term for my final examples. So let's do these then. Because I'm going straight to the nth term in all cases, you can even adapt the little rules slightly. We've always said in the past difference times term number plus 0 term, but if the term number I want for all of these is n, that will always be n. So you could even use that shortcut. Don't have to, but that's how I'm going to do each of these. I will just do difference times n plus 0 term. That will be the answer I need. Okay then, so what's this going up in? To get from 9 to 15, 15 to, I think that's adding 6 each time, isn't it? I think this is going up in 6s. Okay, I will need the 0 term in a minute as well. So 6 less than, that's 3, isn't it? Positive 3. So surely I need 6 times n for the nth term plus 3. That would normally just be written as 6n plus 3. Okay, that's the answer for number 1. The nth term is 6n plus 3. Let's look at number 2 then. What's this going up in? It is still going up. It's going up in 0.5, isn't it? Adding a half each time. Okay, it doesn't have to be a whole number. The 0 term, the one that comes before 8, would be 7.5. So surely this is 0.5 times n plus 7.5, and that would normally just be written as 0.5n plus 7.5. So without the times sign, basically. I don't necessarily need you to use any colours for this. I'm going to carry on just to make this clear. How the various parts work, but you're very welcome to jump straight to this answer. In fact, I probably hope after a while you are confident enough to jump straight to this answer. Okay, number 3 then. This appears to be going down this time. So what are we adding on? We're adding on minus 2. It's taking away 2 each time, isn't it? It's always taking away 2. Therefore, the 0 term would have been a bit bigger than 16. The one before 16 was 18. So for the nth term then, that's minus 2 times n, and the 0 term positive 18. We can just write that as minus 2n plus 18. It turns out there's another way of writing this. If you happen to have a negative at the beginning like that, you can swap these around. You can put the positive 18 first if you like. You don't have to, it's totally up to you. The answers in the book always prefer this version. Most students prefer this version. I don't really mind. It's exactly the same. Both nth terms work. You could use either of these to work things out. So up to you. I don't mind. They're both correct. It's lost its number. Okay, number 4 then. This is going up. It's going up in 7s. So plus 7, plus 7, plus 7. Each difference is 7 then. Well, 7 less than 3, that's a negative number, that's minus 4. So if I want the nth term, difference, 7 times n for the nth term, add on minus 4. There's no point in writing add minus 4. You can if you want to, but adding minus 4 is the same as taking away 4, so just 7n minus 4 is fine. Okay, finally then number 5, it is actually the same as all the others. It's got more negative numbers in it, but it is the same idea as all the others. It's increasing. To get from here to here, I'm adding 3, adding 3, adding 3. It's always adding 3. Okay, people sometimes get a bit scared when they see that many negative numbers, but no need to. It's the same idea. So it's going up in 3's difference is positive 3. The one that would have come before minus 9, well, 3 less than minus 9 is minus 12. You might have been able to guess that by sort of looking at this. It's a bit like the 3 times table spreading out backwards, isn't it? But anyway, minus 12 is your 0 term. So if I want the nth term, it's difference of positive 3, going up in 3, so positive 3, times n, 0 term minus 12. You can write plus minus 12 if you want to, but there's no need to. If you add minus 12, it's the same as taking away 12. So the nth term is 3n minus 12, and you're done. The questions I want you to do will also be find the nth term. You can colour code it if you wish. If you want to really try to understand which parts are which, that's fine, but I'm perfectly happy if you'd go straight to the answer, not a problem. Good luck.